Dear learners of class 12th, today we are going to discuss chapter 13 Amines part 4. After this discussion, you will be able to understand the diazonium salts, describe the method of preparation of diazonium salts, explain their importance in the synthesis of a series of aromatic compounds, including azodies. Diazonium salts are one of the most reactive derivatives of aromatic primary amines, but are quite unstable in nature. Primary aliphatic amines form highly unstable alkyl diazonium salts. Primary aromatic amines form arene diazonium salts, which are stable for a short time in solution at low temperatures of 273 to 278 Kelvin. The stability of arene diazonium ion is explained on the basis of resonance. Benzene diazonium chloride is prepared by the reaction of aniline with nitrous acid at 273 to 278 Kelvin. Nitrous acid is produced in the reaction mixture by the reaction of sodium nitrite with hydrochloric acid. The conversion of primary aromatic amines into diazonium salts is known as diazotization. Due to its instability, the diazonium salt is not generally stored and is used immediately after its preparation. Let us understand the physical properties of the diazonium salts. Benzene diazonium chloride is a colorless crystalline solid. It is readily soluble in water and is stable in cold, but reacts with water when warmed. It decomposes easily in the dry state. Benzene diazonium fluoroborate is water insoluble and stable at room temperature. The reactions of diazonium salts can be broadly divided into two categories, namely reactions involving displacement of nitrogen and reactions involving retention of diazo group. Let us understand the reactions involving displacement of nitrogen in detail. Diazonium group, being a very good leaving group, is substituted by other groups such as chloride, bromide, iodide, cyanide and hydroxyl, which displace nitrogen from the aromatic ring. The nitrogen formed escapes from the reaction mixture as a gas. Replacement by halide or cyanide ion. The chloride, bromide and cyanide nucleophiles can easily be introduced in the benzene ring in the presence of copper plus iron. This reaction is called Sandmeyer reaction. Alternatively, chlorine or bromine can also be introduced in the benzene ring by treating the diazonium salt solution with corresponding halogen acid in the presence of copper powder. This is referred as Gattermann reaction. The yield in Sandmeyer reaction is found to be better than Gattermann reaction. Replacement by iodide ion. Iodine is not easily introduced into the benzene ring directly, but when the diazonium salt solution is treated with potassium iodide, iodobenzene is formed. Replacement by fluoride ion. When arene diazonium chloride is treated with fluoroboric acid, arene diazonium fluoroborate is precipitated, which on heating decomposes to yield aryl fluoride. Replacement by hydrogen. Certain mild reducing agents like hypophosphorus acid, phosphenic acid or ethanol reduce diazonium salts to arenes and themselves get oxidized to phosphorus acid and ethanol respectively. replacement by hydroxyl group. If the temperature of the diazonium salt solution is allowed to rise up to 283 Kelvin, the salt gets hydrolyzed to phenol. Replacement by nitro group. When diazonium fluoroborate is heated with aqueous sodium nitrite solution in the presence of copper, the diazonium group is replaced by nitro group. Let us understand the reactions involving retention of diazo group. And these reactions are known as coupling reactions. The azo products obtained here have an extended conjugate system having both the aromatic rings joined through the nitrogen-nitrogen bond. These compounds are often colored and are used as dyes. Benzene diazonium chloride reacts with phenol, in which the phenol molecule at its para position is coupled with the diazonium salt to form para-hydroxyazobenzene. This type of reaction is known as coupling reaction. Similarly, the reaction of diazonium salt with aniline yields para-aminoazobenzene. This is an example of electrophilic substitution reaction. Methyl orange, a very useful indicator in acid-base titrations, is a product of the coupling reactions. From the reactions discussed, it is clear that the diazonium salts are very good intermediates for the introduction of fluorides, chlorides, bromides, iodides, cyanides, hydroxyl and nitro groups onto the aromatic ring. Aryl fluorides and iodides cannot be prepared by direct halogenation. The cyano group cannot be introduced by nucleophilic substitution of chlorine in chlorobenzene, but cyanobenzene can be easily obtained from diazonium salt. Thus, the replacement of diazo group by other groups is helpful in preparing those substituted aromatic compounds which cannot be prepared by direct substitution in benzene or substituted benzene. To summarize this discussion, let us recall the points discussed. Diazonium salts are formed as a result of carrying diazotization reaction of aniline. Structure of diazonium salt is supposed to be derived from ammonium salt, such as ammonium chloride, by replacing 3 hydrogen atoms with nitrogen atom, and the fourth by a phenyl group. Diazonium salts are highly reactive chemically and are helpful in the synthesis of a large number of aromatic compounds. Benzene diazonium chloride participates in coupling reactions with phenol and aniline under ice-cold conditions to form colored compounds known as azo dyes. Before we end this discussion, let me leave you with an assignment. You are expected to explain the following conversions as mentioned on the screen: nitrobenzene into aniline, ethanoic acid into methanamine, aniline into N-phenylethanamide, ethanamide to methanamine, 4-nitrotoluene into 2-bromobenzoic acid. I hope you understood all the concepts discussed in this discussion. Wishing you all happy times ahead. Take care, stay safe and stay healthy.